Okay, that's way too bright. Auto image. Alright, this is 12-1. Like I said in class the other day, this unit is kind of random because they've basically just thrown all of the other two-dimensional shapes into one unit. So we spent a whole bunch of time on triangles, we spent a unit on quadrilaterals, and we're basically studying all of the other two-dimensional shapes, which is basically regular polygons and circles. The entire rest of the unit will be about circles. Okay, a tangent line has nothing to do with the tangent, the trig tangent that you've already learned. I don't know why it's the same word. Just sometimes in English we use the same word to mean two different things. But do not confuse this with the tangent from sine, cosine, and tangent. Tangent line is just a line that intersects a circle in exactly one point. So if I have a circle, I can draw lines outside the circle and I can draw lines inside the circle. If I drew it inside the circle, it would intersect twice. My third option is a line that just barely touches the edge of the circle at one point and then continues on. This would be called a tangent line. The point where it intersects is called the tangent point. Okay? You will see this terminology again when you do calculus, if you ever get to a full-blown calculus class. Some of you will. And that is called a tangent point. You'll see it. You'll study tangent points on graphs later on in life. Alright, theorem 12-1 says that the tangent line is, remember that symbol means perpendicular to the radius. So if I have a circle and I draw a tangent point and I draw a tangent line and I draw the center of the circle and draw the radius to that point, then those two lines are perpendicular. So you know for a fact that that is a 90-degree angle. So again, this is the, let's see if I can get my pen working, tangent line, and this is my radius line. Radius line. Okay, and those two lines will always be perpendicular. So, I have a circle. I'm going to use my ID as a straight edge. I have a circle, and I draw that tangent line, and I draw that tangent line, and I draw that radius, and I draw that radius, and I tell you this angle is 60 degrees, find x. Okay. According to this theorem up here, according to theorem 12-1, this is a 90-degree angle. And according to 12-1, this is a 90-degree angle. And according to the section you just learned yesterday, all four of these angles, since this is a quadrilateral, 1, 2, 3, 4 angles should equal 360. So 90 plus 60 plus 90 plus x equals 360. These four lines make a quadrilateral, which means their angles add up to 360. That angle was given to us. These two are 90 degrees, and x is our fourth angle. So if we solve that, you get 120. So we would just subtract it all over. Okay? Example 2. Draw a tangent line. Draw the center of the circle. Connect it here. And connect it here. And if I tell you that that length is 2.5, and this length is 6.5, and that is 6, question is this a tangent line? Now, obviously, looking at the picture, you would think that it is, okay? But we never like to assume things in geometry because you don't know. If we zoomed way, way, way in on this point, we might see the line go through 2 points in the circle instead of 1. So you never want to judge, you never want to trust your eyes, okay? So it looks like it should be a tangent line, but we're not sure. So how would we check? Well, according to 12-1 says that this is A, B, C. 12-1 says B, angle B, should equal 90 degrees, which means it's a right triangle. Right? How do we check if it's a right triangle? Pythagorean theorem. So we're going to do Pythagorean theorem to see if it's a right triangle. So 2.5 squared plus 6 squared is supposed to equal 6.5 squared. That gives me 6.25 and 36 and 42.25. When I add these together, I get 42.25. So we have proven that it is a right triangle, which means yes, it's a tangent line. Okay. Theorem 12-3 says if two segments are tangent to the same circle and come from the same point, then they are congruent. That's a lot of words. Let's go over it again. We have two segments, okay, and a circle. So if we have a circle, and I draw two tangents, draw that tangent and that tangent, and it says they come from the same point. That means they're starting at the same point, and they're both going off of this point, and they're both tangent to the circle. What that is telling you is that this segment and that segment are equal. Okay? So, example 3. If I have a triangle, and I have a circle inscribed inside the triangle, okay. That's 6, that's 13, that is 9. Okay. We want to find the perimeter. Okay? So, according to our theorem, we're going to look at each vertex. If this is 6, what is this distance? 6. But we're told the entire distance is 13. So, 13 minus 6 gives us 7 for this distance. Okay, so we started here. We're just going around the triangle. This is 6, this is 6. Therefore, to make 13, this must be 7, which means this must be 7. Okay, and they tell us this is 9, so that must be 9. The biggest mistake people make is thinking that these two have to be equal. A lot of people would tell me that this is 6, so that has to be 6. It's not true. You're only looking from the vertices. Those are equal, and those are equal. And then perimeters, just add it all up. Okay? So 6 plus 6 plus 7 plus 7 plus 9 plus 9. Apparently I didn't write this answer down last year, so that's 12, 14, 18, 26, 14, 44. I don't know if I did that. If I did that wrong, you can correct me in class, but I'm pretty sure I did that right. Okay, and that's it.